Well, good morning, Algebra. Welcome to our second week for the midweek feedback video. Hope you guys are having a good morning. It is right now 9:20 a.m. here on Friday, April 17th, and I'm guessing about over half of you might still be in bed. It's a very realistic possibility, but that's all right. You'll still be able to see this content here when you do eventually see it. Otherwise, in other news, it is snowing right now outside. That is the view I am looking out at right here out my window. But we're not going to talk about that because we're going to pretend like that's not actually happening. So anyways, let's get right into it. Midweek feedback. This was the hardest question here on the first assignment, and then I'm going to pause it, and then we'll look at the second assignment in a second. But this is, I can see why this one's the hardest. You just had to do a bunch of matching here. And once again, you might have different numbers than I do potentially here. But anyways, should be pretty similar. All right, so let's look at part A here first of all. So notice here, we need to look just at the denominator and see where's the radical at? Is it a monomial or a binomial? And how would we actually cancel or rationalize and get rid of that radical in the denominator? So the first one, x minus square root of 3, it is a binomial, right? It's two terms, x and square root of 3. And so here's where we would use the conjugate. So the conjugate, once again, would be those same two things, x and square root of 3, except you would exchange the minus sign for a plus sign. And you would have to multiply that, of course, on top and bottom, or else you're changing the overall fraction, which we're not allowed to do. So here, I could go ahead and match that with x plus square root of 3, top and bottom multiplied, and that would rationalize that denominator. All right, part B, we've got just a monomial on the bottom. It's only square root of 3, so we can just multiply square root of 3 on top and bottom. Part C is a little tricky. Notice here it's the fourth root, and then it's x to the third. So if you think about it, you could only free something. And I know we wouldn't always necessarily talk about it in these terms, but this might be helpful. But you can only free something from the radical if you actually complete the group. So most square roots, there's no number written up there, but it would be a 2, right? It would be the implied number, which means as soon as you have square root of x squared, you can actually, of course, get rid of the radical and bring that out as one group of 2 x's, that you would then bring out to the front. And of course use absolute value with it. But in this case here, a fourth root, we need a group of 4. Right now we have 3 x's inside. We're just shy by 1. If we could just multiply by fourth root of x to the first, then you could put the 3 and the 1 together, and you would end up having fourth root of x to the fourth, and then you could get rid of the radical. So what we're looking for here would be the fourth root of x to the first. That would give us that fourth x, and we could actually get that complete group of 4, and we could then free it from the radical. All right, next one here, same kind of idea here. We've got a cubed root. First of all, if you're looking for the lazy way, of course, we're thinking, well, it's going to have to be a cube root of some kind. So there's only one cubed root up here, just like there's only one fourth root. But notice here, we had 2 y's. We needed one more y. And then this one's kind of a little trickier, but if you think about it, we would have to do 9 times 3 to get cubed root of 27, which would actually turn into 3 without any radical left. So, all right, next one here. We would once again do square root of 3 on top and bottom. Since it's just a monomial, it's only square root of 3 down there. The next one, it's a monomial, but the only radical is square root of x. So that's all we have to worry about would be square root of x on top and bottom. All right, so that would be the question. We can check how we did, and it says excellent. So I guess we're off to a good start. All right, and then let's go ahead and move on to Friday's assignment. Now, I wanted to go ahead and try and get the video out a little bit earlier here today so that you can actually see it, since everything's due here on Monday, which isn't too far away now. And so actually, everyone who's done the assignment has a 10 out of 10 already. So I don't know exactly which ones are hard and which ones aren't for you guys, but I'm going to go ahead and go through one of them just in case you want to hear one kind of talked through, and that might be enough maybe for a lot of you guys to kind of get what's going on. And once again, if you need help, you can always hop on Zoom today or shoot me an email over the weekend, and I will try to get to that there before Monday morning at 8:30. So let's go ahead and look at this one. So this would be Friday's assignment where we're solving a radical equation. So remember, the biggest thing we need to keep in mind right away is that we need to isolate the radical. Right now I have that x that's on the left side here that I need to move over so that I can get the radical by itself on that left side. So if I do that, I get radical 2x plus 18 equals here, and then we would have x plus 9 at that point on the right side. Now I'm able to actually square both sides. And so let's go ahead and do that. Now squaring, of course, the strategy is that allows us to cancel out here this square root. So we're just going to be left there with 2x plus 18. So that stays the same. It just clears out the radical, which is what we wanted to do. We wanted to kind of get rid of the radical. Now over here, notice x plus 9 squared is actually x plus 9 times x plus 9. Don't make that mistake. Make sure you would FOIL that out, including the middle term. So it would be x squared plus 9x plus 81. So that should be x squared plus 18x plus 81. So that's what we're going to, of course, put over here. All right, so that was the big first goal, was first isolating the radical, and then second, squaring both sides in order to abolish or get rid of the radical. Noticing that the left side actually stayed the same because the radical was the thing that got knocked out there. Here, there was no radical, so it got squared. Yeah, that happened. So otherwise, we're going to get everything onto the same side here. So let's go ahead and move over the x's and the numbers. The reason I'm getting everything on the same side when we solve this kind of equation is because if you notice, it's quadratic. And so whenever we would have x squared and we would try to solve it earlier in the year, we would always have to get everything on the same side. So we get 0 equals x squared plus 16x. And then let's see, that would be, oh gosh, mental math on the fly here. That would be what, 63 right there. And that's plus 63. All right, and then from there, now we can see maybe we can factor it. If we can't, we'd have to use quadratic formula, but let's try factoring it first here. In this case here, we're going to have an x and an x, and then we want factors of 63 because it's positive that would add to that number there of a 16. So I'm thinking, what, 9 times 7 there? 9 times 7, 63. 9 plus 7 is 16. Okay, so we got those two things. To solve it, we set each of those equal to 0. That means we get x here is equal to -9 and x is equal to -7. Now we just need to double check our answers. Remember, the big thing about radical equations then here at the end is make sure that we check those answers. So as we're doing that here, we would go back up to this original equation up there, and we'll try and plug in what we got here and see what it does for us. So let me get a little bit of, oops, I didn't think that was going to do that. Let me, well, this is awkward. Let me try and rewrite that over here. So we'll do that, minus x, I think it was, equals 9. All right, so plugging those in, let's kind of picture it here. So putting there a -9, we would have 2 times -9 is -18, plus 18 to give us 0. So square root of 0 is 0, minus -9, which is actually like adding 9, would be 9. So I do find that we get 9 equals 9 for that one. So we're good with this one. That would be one of our solutions. Now let's plug in -7. So -7 times 2 would be -14, plus 18 would be +4. Square root of 4 is 2. So we'd have 2 minus, what, -7? Now we'll see if that's equal to 9. That is also equal to 9. So in this case, they both worked out. Remember, that won't always happen. But in this case here, we'd have to say that both of those solutions there would be, or both of those numbers we got would be solutions. So if we were typing into Canvas, of course, using curly braces, and that would be our answer. So once again, that's one example from the homework today. If you need more help, don't be afraid to reach out to me. Otherwise, I hope you guys have a fantastic weekend, and we're going to hope it stops snowing. I think it's supposed to be somewhat warm on Sunday. So here's to hoping for that. So, all right, we'll see you guys later.